Welcome to this introductory presentation for tekmar's newest product, the Boiler Control 284, a flexible control solution for commercial and multi-residential heating plants. My name is Elizabeth Brown. I am a technical support specialist at Tekmar Controls, and I will be your host for today's webinar. The Boiler Control 284 is designed to operate up to 4 boilers to accurately maintain a target water temperature based on outdoor temperature reset or a fixed set point temperature. The 284 operates any combination of condensing and non-condensing boilers that are modulating single-stage or two-stage to provide a very flexible, cost-effective mixed boiler plant solution with better system performance. Since we allow you to configure each boiler individually, the 284 really does control any combination of boiler types. This control will apply specific logic to operate your unique heating plant to achieve ultimate system efficiency. And we'll learn more about how it does that as we continue in this presentation. The 284 addresses the present market and future growth of heating plants by supporting mixed boiler plant systems that include condensing and non-condensing boilers. Target markets are looking for the balance between high efficiencies and lower capital costs, and that balance can be achieved with a mixed boiler plant that includes condensing and non-condensing type boilers, if controlled with a sequencing algorithm that considers how efficiency varies with boiler type. And that is exactly what the 284 has been designed to do. The 284 also supports multiple modulating boilers that require a target temperature signal, like the Wiesmann Vitadin's 100 and 200 models. It is superior to cascading controls, which are costly and typically only operate boiler plants with equivalent boiler types, whereas the 284 can efficiently control any combination of different boiler types. Target markets include small commercial applications like multi-residential, apartments, or fire halls, mid to large commercial buildings with building automation system capability like universities, institutions, and hospitals, and some large custom residential homes. The 284 is a designer series multi-staging boiler control that is able to integrate with building automation systems using BACnet IP or Modbus. It provides building managers with the ability to remotely monitor and even adjust the heating system, which is an important feature in today's market. The 284 does not replace the 274, 75, or the 265, but it does provide the same staging capability, but with increased functionality and additional features. We'll begin by outlining 5 targeted applications for the 284 boiler control, and these applications will highlight the versatility of the 284. Next, we'll explore the features that are new to the 284. These, in conjunction with the boiler control features that you're already familiar with, are what make this control so unique. The customization of features can provide a control solution that is specific to your particular application, or it can enhance the performance of an existing building automation system. Lastly, we'll briefly look at the wiring to the 284 to emphasize the ease of installation with the large enclosure and the dedicated terminals. The 5 applications that feature the best in boiler plant control include a combination of condensing and non-condensing boilers so that we can really highlight how this control will operate a mixed boiler plant. We're also going to look at domestic hot water generation, both indirect domestic hot water, which we refer to now as IDHW, and dedicated domestic hot water, which we will refer to as DDHW. And this is a distinction that you'll have to make going forward, is the IDHW for indirect versus the DDHW for dedicated. Our indirect domestic hot water is specified as either near boiler piping or boiler system piping, and we'll look at that a bit closer as we go through the applications. Lastly, we're going to look at some primary pump sequencing in combination with IDHW or indirect domestic hot water. This first application is showing a mixed heating plant. We have 2 single-stage non-condensing boilers, and we have 2 modulating condensing boilers. And all 4 boilers are being used to provide heat for indirect domestic hot water, a set point load, and for space heating. You can see we have 4 space heating zones equipped with TRVs. Also note we were doing primary pump sequencing for a standby operation of the primary pump. We can do this along with indirect domestic hot water, whereas in the 274 and 275 it was one or the other. With a 284 we can do both, so a real advantage to the 284. Looking up top, I can see that I'm communicating with a building automation system using Modbus or BACnet IP. I'm also communicating to a gateway 483 using the tekmarNet communication, which will allow for remote monitoring. I have an outdoor sensor to provide outdoor temperature reset. I'm also controlling a combustion air damper. And notice here that the end switch from the motor is connected back to the 284 to provide proof of combustion air, which is an optional feature on the 284. How are we proving flow for the primary pump operation? We're doing that with a flow sensor F1. The type of flow sensor that can be connected to the 284 is a 0 to 10 volt analog vortex type flow sensor. And this same flow sensor can be used to provide proof of flow. It can also be used to measure flow, and we can communicate that flow measurement to the building automation system. If I have a flow sensor, a boiler supply sensor, and a boiler return sensor, then I can do an energy calculation. And that energy usage can also be communicating to the building automation system for remote monitoring. Other sensors on the system include a boiler inlet sensor, S5, and each of the boilers has its own boiler outlet sensor. And I can use that outlet sensor to set a boiler max temperature for each boiler, so that if the outlet temperature on a boiler exceeds the boiler max setting, the 284 will shut that boiler down. Because I have the inlet sensor and the outlet sensor for every boiler, I can also do a delta T measurement across every boiler. And that is also information that can be communicated to the building automation system. Our second application shows 4 modulating boilers that are being operated to provide space heating and indirect domestic hot water. You can see that the 4th boiler is solely responsible for the indirect domestic hot water generation. So the way this will operate is all 4 boilers will provide space heating to the load, which we don't see pictured here in this diagram. But if there's a domestic hot water call, the 4th boiler will operate to provide water for the domestic hot water operation alone. So P6 will shut off and P7 will operate instead. We do have, again, our boiler inlet sensor S5, and we have individual boiler outlet sensors so that we can do our delta T monitoring. Notice here that we have an outlet sensor for the 4th boiler, and we also have a domestic hot water sensor. Now this is different than what you might have noticed with the 275, 274, when this type of domestic hot water generation was referred to as mode 5. And in mode 5, in the previous generation of controls, we did not have a domestic hot water sensor. We measured the domestic hot water temperature from the boiler outlet sensor. So now we have changed this operation so that we can accommodate a domestic hot water sensor if we are doing this type of piping, which we refer to from now on as near boiler piping. So we have IDHW here with near boiler piping, and the near boiler piping must be off the 4th boiler. Again, we have dual primary pumps. This time we are proving flow with current switches instead of the flow sensor. So we do have that flexibility. You don't have to use the flow sensor to prove flow. You can use any type of flow proving device. Our third application shows dedicated domestic hot water, which we refer to now as IDHW. Now this shows 4 on-off boilers. In this case, they happen to be 4 2-stage non-condensing boilers, and they're being operated to provide a fixed set point temperature for a dedicated domestic hot water load. In this case, we are operating a recirculation pump. Now on the control, we can operate either a recirculation pump or a combustion air damper. We use the same relay for both, so it has to be one or the other. Again, we have our boiler inlet sensor, individual boiler outlet sensors so that we can do that delta T across the boilers. This also lets us do a boiler max for each individual boiler. So instead of a max for the system, a new feature for the 284 is to have a boiler max temperature for each boiler. And if we rise above that limit, the 284 will turn that boiler off. So that's another advantage, a new feature to the 284 boiler control. This application shows two modulating condensing boilers that are being operated to provide heat for space heating and for indirect domestic hot water. This is what we refer to as boiler system piping. So the indirect domestic hot water is not near one of the boilers, it's on the boiler system, so we call that boiler system piping. We have our space heating zones. tekmarNet thermostats are all TN2 in this case. They're connected to a wiring center, which in turn is connected to the 284 to provide indoor temperature feedback. The outdoor temperature reset, which is possible because of this outdoor sensor connected to the 284, plus the indoor temperature feedback, saves energy by operating the boiler plant using the lowest possible temperatures. And lower water temperatures are, of course, excellent conditions for the modulating condensing boilers. It allows them to operate at maximum system efficiency. You can also see here there is S8, and this is what we call a vent sensor. And we can connect a vent sensor to the 284, and we can use that sensor to monitor vent temperatures. We can also select a limit, so that if the vent temperature were to rise beyond that limit, we would shut the system down. So that, again, another new feature for the 284 is the option of connecting a vent sensor for monitoring purposes and for limiting purposes as well. You can see the 284 here is connected to a gateway control. It could be a 482 for home automation, or the 483 to allow the user to remotely monitor and adjust thermostats. Our last application again shows two modulating non-condensing boilers, and these boilers are being operated to provide a boiler target temperature for space heating and for indirect domestic hot water. Again, this indirect domestic hot water is on the boiler system side, so it's IDHW boiler system side location. You can see we have two primary pumps that are being sequenced in a standby operation, and we can also configure the two primary pumps for equal runtime if that is desired. We are proving flow here with a pressure differential switch, even though we do have a flow sensor. So the flow sensor does not have to be used to prove flow. We can use that flow sensor just to monitor flow, which is what we're doing in this case. We have two domestic hot water pumps that are being controlled in this case by a 132 pump sequencer. So the domestic hot water pump output on the 284 is being used to provide the pump demand on the 132, and the 132 is taking care of that domestic hot water pump sequencing. And of course we would have to prove flow. Here we are proving flow with a flow switch. You can see the space heating zones are equipped with TRVs. So this is a type of application that you might find in a small apartment complex where we have one thermostat located in the boiler room, and we have individual indoor sensors in the units. Now those indoor sensors can be connected to the 538 tekmarNet 4 thermostat using series parallel wiring. And because we're using series parallel wiring, it has to be a perfect square number. So we could use 4 sensors. The next number we could use would be 9, and the next number we could use after that would be 16. So these sensors are going to provide indoor temperature feedback that will fine-tune the boiler supply temperature from that outdoor reset temperature. And what that's going to do is save energy by operating the heating plant efficiently and prevents tenants from opening the windows because they're too hot. S8 here is a pressure sensor. Now the pressure sensor is another new feature for the 284, and it allows us to monitor the pressure in the system. We'll talk about that pressure sensor more later in the presentation. The 284 has more features for the most flexible, efficient boiler plant solution, and we're going to look at 10 of those new features in this presentation. We'll start with the specialized control logic that the 284 has to operate up to 4 condensing and non-condensing boilers, be them modulating single stage or two-stage. The 284 can treat each boiler differently, and we'll look at how it does that. Outdoor temperature reset is one of the applications that this control features. If this isn't the type of application that you have, we'll also look at how you can configure the control to do something else. BACnet or Modbus communication. We'll touch on those today. More information on this will be included in the upcoming technical webinar. You can also find more information on this in the BAS manual that can be downloaded from our website at www.tekmarcontrols.com. You of course are familiar with tekmarNet communication, but we're going to emphasize how it can augment the capability of the 284. Performance monitoring, in particular energy flow and pressure monitoring. No other control on the market is able to measure and communicate all the information that the 284 can. We did look at primary pump sequencing in the applications. It is for standby operation only. We can't do two-stage primary pump sequencing, only standby. And the way the 284 does the standby operation is a little bit different from an earlier control, so we'll clear that up when we get to this item in the presentation. Indirect domestic hot water operation we did see in the applications and we've talked about already, but I do want to emphasize the terminology that we have now of near boiler piping versus boiler system piping. And that instead of modes, now we are going to enter in the location of the indirect domestic hot water. And we're going to tell the control if we want the primary pump to operate or not. So a move away from modes and a move towards a more clear explanation of where the indirect domestic hot water is. We looked at Setpoint Operation in the applications as well. What we're going to talk about when we get to this item is how a setpoint call can be triggered. There are 3 ways to trigger a setpoint call on the 284. And lastly, the touchscreen user interface. That makes this control very easy for the installer to set up and very simple for building managers to view and adjust. These are the features that we're going to cover in the presentation, but of course this control also features the same things that are common to the 274 and 275, such as warm weather shutdown, automatic differential, domestic hot water priority, equal runtime rotation and pump exercising, pump post-purge, and the fixed lead, fixed last operation that you're familiar with. Because we're also controlling modulating boilers, we can set up the modulating mode as sequential or parallel as well. We're not going to go into these today because you're already familiar with the operation of these features. As we've said, the 284 can control the mixed heating plant, which is becoming more common in today's world as building owners are seeking high system efficiencies with lower capital and operating costs. And the mixed boiler plant can do that as long as it's controlled properly. And the 284 is a flexible control solution for these types of mix and match applications. If there is more than one condensing boiler being configured, the 284 will automatically create a condensing boiler group. Likewise, if there is more than one non-condensing boiler being configured, the 284 creates a non-condensing boiler group. Rotation happens separately within each of these groups, which makes sense because it's very likely that each of these groups will have different run times. Up to 4 boilers are independently configured on the 284. It's difficult to find proper control for different types of boilers, but the 284 is flexible enough to operate boilers that are either modulating, single stage, or two-stage. This truly is a control that can be customized for your particular boiler plant design. There are 4 boiler banks, and each bank has 6 terminals. We have our modulating plus-minus terminals, our stage 1 terminals, and our stage 2 terminals. If we are operating a modulating boiler, we will connect to the mod plus-minus terminals. If that boiler also needs an enable, we will connect to the stage 1 terminals as well. The modulating output can be configured for a firing rate target using 0 to 10 volt or 4 to 20 milliamp output, or it can be configured for a temperature-based target with the EMS1 and the EMS2 configurations. EMS2 is what we use to control up to 4 Viessmann Vitadin's 100 and 200 boilers. On-off boilers are connected to the stage 1 terminals and or the stage 2 terminals. If we have a single stage boiler, we will connect directly to stage 1. If we have a 2-stage boiler, we will connect to stage 1 and stage 2. The 284 can be configured for one of the 5 application modes. We have the outdoor temperature reset mode, and 4 of the 5 applications that we reviewed in this webinar were the outdoor temperature reset mode. If that's not what we're looking for, we can set up the 284 for a fixed set point mode, for dedicated domestic hot water mode, which was one of the other applications that we saw. We can also configure it to receive input from an energy management system or from a building automation system. Now, how do these different application modes differ? Well, one of the ways they differ is on the number of water temperatures that they allow. If we're in outdoor temperature reset mode, we can have a space heating water temperature plus a domestic hot water temperature and a set point temperature. So this application mode accommodates 3 different water temperatures. If we're in the energy management system application mode, the input we receive will be for space heating, and we can also accommodate domestic hot water set point call and a set point call. So 2 additional calls can be connected to the 284 for 2 additional water temperatures. If we're in fixed set point application mode, we can't do space heating, but we can do our set point operation and domestic hot water. In dedicated domestic hot water mode, we can only do domestic hot water. That is the only water temperature that we can configure. And in building automation system mode, we receive input for a single water temperature, and that water temperature could be used for anything. It could be used for set point or domestic hot water or space heating. The boiler control 284 can communicate with a building automation system using BACnet or Modbus, and can also communicate with a gateway 483 using tekmarNet communication. Remote monitoring and adjustment is possible through communication with the building automation system, and is also possible with the TN4 connection to the gateway 483. Just a note here though, the gateway allows adjustment of thermostats only, whereas communication from building automation system using BACnet or Modbus provides greater adjustment capability. Let's talk a bit more about the BACnet and the Modbus communication. They are both HVAC industry standard communication protocols. I've been asked before, can we do both? Can we have BACnet and Modbus at the same time? No, you cannot. It is one or the other. The BACnet IP connects from the RJ45 port on the top of the 284 control. The Modbus connection is through 3 terminals, terminals 40 to 42. The connection is with a shielded twisted pair with a signal ground. So the shielded twisted pair are in terminals 40 and 41, Modbus A and B, and then we have our ground wired into terminal 42. Now we have applied for BACnet testing laboratory certification, BTL certification, and that certification is currently pending. We're not sure when that will become available to us, but it is in the works. As I said, both BACnet and Modbus communication allow us to remotely monitor our system and allow for some adjustment. The level of adjustment depends on the mode that we are in. So if we're in the monitor mode, we may be allowed some adjustments to the heat curve if we are in outdoor temperature reset application mode. And we can also control the boiler enable in the monitor mode. If we're in the temperature mode, we can make adjustments to the set point call, the set point target, primary pump enable and disable, IDHW pump enable and disable, and of course the boiler enable disable. So obviously the temperature mode allows for greater adjustment capability, and that is only if we are in the BAS application mode. Now I know this is a lot to digest at the moment, the different application modes and the different BAS modes. We will cover this in greater detail in the technical presentation coming out in the next month, and this information is included in the B manual that can be downloaded off our website. tekmarNet communication allows us to provide indoor temperature feedback. Now we can connect tekmarNet devices to 4 TN4 buses. There are 4 TN4 buses on the 284 boiler control. And we have the same rules about the number of devices per bus. It's 24 devices per bus. What that does is give us a total of 96 possible devices on the tekmarNet network. Now, all of these are the boiler bus. It's all boiler bus water temperature. Just to be clear of that, there is no mixing available on the 284. So with all those tekmarNet devices connected to the boiler buses, we can have indoor temperature feedback to the system, and we can also have zone synchronization on our system. Of course, we can also connect to a gateway control, a 483 if we want to remotely monitor our system and adjust our thermostats, or a 482 if we're trying to configure our system to be compatible with the home automation system. Now, what information can be communicated to a building automation system? Well, in addition to temperatures, system performance monitoring information can also be communicated. The first of those indicators that can be measured and communicated is flow rate. If we are connected to a flow sensor, and the flow sensor, as I mentioned before, is a 0 to 10 volt analog vortex style flow sensor. If we have that, and we also have the boiler supply sensor and the boiler return sensor, then we can calculate the energy usage and we can communicate that to the BAS as well. If we have a pressure sensor in our system, then we can measure pressure and communicate that to the BAS. The pressure sensor would be a 4 to 20 milliamp pressure transducer, and we measure pressure in PSI or kilopascals. We talked about that vent sensor before, so we can measure the vent temperature and communicate that to the BAS. Ones that you would expect are the boiler temperature, boiler runtime, and cycles. And because we have the boiler inlet sensor and individual boiler outlet sensors, we can communicate individual boiler information as well as the boiler delta T. We can also communicate the runtime for the pumps, and that includes the primary pump and the domestic hot water pump. Competitor products do not feature all of these performance measurements. We are the only one that has this combination of performance monitoring indicators that can be measured and communicated. The 284 has a built-in pump sequencer so that we can operate the primary pumps for standby operation and equal runtime if we so choose. Now, I said earlier that there is a twist on how the 284 sequences the primary pumps, and there is. What is new to the 284 is that we have 2 attempts at operating the pumps. So we'll start by trying to operate the lead pump. If flow is not proven, then we will try and operate the lag pump. If that doesn't work, we're going to try to operate the lead pump one more time. And if that doesn't work, then we'll try and operate the lag pump one more time. So the 2 attempts at operating the primary pumps is what is new in the 284 boiler control. Well, this is because emergency service calls are expensive and service contractors want redundancy so that if a pump fails, a lag unit automatically turns on. So we're going to try that twice to make sure before we shut the system down there is indeed a problem. I mentioned before the indirect domestic hot water operation and how it's important here to distinguish between near boiler piping and boiler system piping. Because in the 284 we are no longer using domestic hot water modes to configure the control. So in the past we would have chosen mode 1 up to mode 5. This isn't very intuitive for people. So if someone is trying to look at the control to readjust the control, those mode selections would require someone to refer back to their manual. So what we've done in the 284 is change that. Now we are not going to use modes. We're going to require you to enter the location. So is the indirect domestic hot water piped near the boiler, or is it on the boiler system side? you select the location. So it's very intuitive. If someone else, other than the person who set it up, is now trying to service or make any adjustments to the control, it's very easy for them to see how it's been configured. The 284 does have setback capability, so you can operate the indirect domestic hot water on schedules. And just like the other controls, this has optional priority for the indirect domestic hot water operation. One thing I do want to point out, I know I said it before, but the near boiler piping must be on boiler number 4. So in this system we only have 2 boilers. We would probably configure this one to be boiler number 1, turn boilers 2 and 3 off, and set up boiler 4 in this case, so that we have that near boiler piping for the indirect domestic hot water operation. A set point call is required in order for the control to provide heat to a set point load, such as a spa or a pool or even a snowmelt load. But I do want to emphasize that the call can be provided through one of 3 ways. It can be provided from a simple contact closure at the set point call terminals. It can be provided through the TN4 communication from a set point control 161 or 162, or it can be communicated from BAS communication. The touchscreen user interface makes it really easy to configure this control, whether you're installing it for the first time or you're trying to adjust it and fine-tune the operation. Pushing the home button for 3 seconds will let you access the different menu selections, and then you can scroll through using the next or the item back button, which is a really nice feature. If you accidentally skip over one of the settings, you don't have to scroll all the way through. You can just use the item back button. Especially nice in this control because there are a lot of settings that we have to set up. You'll see on the screen too, we have boiler 1, boiler 2, boiler 3, boiler 4. And right now it shows 100% for all of them. You might guess that you can actually see the output of each of the boilers on this screen, and you would be correct. If you have a single stage boiler, it will show up as 100% output. If you have a 2-stage on-off boiler, if only the first stage is on, it'll show up as 50% output. If stage 2 is on, it'll show up as 100% output. If you have a modulating boiler with a firing rate target, the percent modulation will appear here. And if it is a temperature-based target using the EMS1 or the EMS2, you will see the temperature. So very convenient that we can just look at the touchscreen user interface and we can see what's happening in our system, how each of our boilers is performing. Just like in other controls, you can see the calls that are in effect. You can see if the primary pumps are on, and of course as well the boiler pumps if they're on or not. The 284 is very easy to install, and that has to do with the large enclosure and the dedicated terminals. There are a lot of terminals on this control. Now, we've tried to separate the wiring with the low voltage at the top and the higher voltage on the bottom. The exception to that would be the auxiliary relay over here, and we'll talk about that more when we get to that item. You can see this is where we wire our calls, and there are 5 different calls that can be connected. Our flow-proof call, and that would be if we are using something to prove flow for the primary pump sequencing. If we are using a flow sensor, then we simply connect a jumper across these 2 terminals. However, if we're using any other flow sensing device, we would connect that to the flow-proof call terminals. Our next set of proof call is the CA proof call. So we can connect the end switch from the motor, from the CA damper, into the CA proof call. We have terminals for heat call. So that can be provided from a thermostat closure. It could be provided from an end switch call. Of course, if we're using tekmarNet communication, we don't need to hook anything up to those terminals. Here we have our IDHW call terminals so that we can connect an aquastat into these terminals. And we have the Setpoint call terminals, so we could connect a thermostat closure into these call terminals. This is the manual override button, which is a new feature for the 284, and it replaces the max heat function. The problem with the max heat function is that not only did it operate the equipment, but it turned the boilers on too. And sometimes you may want to try and operate the equipment without turning the boilers on. And the manual override function allows you to do that. There are 5 different modes that you can select. And if you select the hand mode, you can actually choose the equipment that you want to operate one by one. So it allows you that flexibility to test your system, see how it's operating the way you need to test it, as opposed to the max heat function. Here are the sensor input terminals, and there are a lot of them. We can connect our pressure sensor and our flow sensor here. We have our EMS input, and this is what's nice on the 284. On the other controls, the older controls, the EMS input had to go through the outdoor sensor terminals, and now we have dedicated terminals for the EMS input. We have terminals for our boiler supply sensor, our boiler return sensor, domestic hot water sensor, and you can see here it's not labeled IDHW or DDHW because we can connect a domestic hot water sensor in either dedicated domestic hot water or indirect domestic hot water operation. We have terminal for the vent sensor that we talked about, the boiler inlet sensor, and then there is an option to connect a boiler outlet sensor for each of the 4 boilers. For communication, you can see we have our BACnet connection over here, and that would be the RJ45 port at the top. And we have our Modbus communication terminals over here. As discussed, there are 4 TN4 buses. We have bus B, bus 1, 2, and 3. Now, it says clearly they are all boiler bus, just so there's no confusion. We cannot have any mixed buses on the 284. They all have to be boiler bus, but because we have 4 buses, we can connect up to 96 devices. We could also use these terminals to connect to a gateway control as well. Over here we have our auxiliary and our alert relays. Our auxiliary relay, terminals 43 and 44, can be used to connect either a domestic hot water recirculation pump or the combustion air damper. It's one or the other. We only have the single relay. And we have the alert output as well. There is an exclamation point here because if you are connecting the domestic hot water recirculation pump, it will be line voltage. So it is the one area where we have line voltage on the upper side of the 284 control. The rest of the line voltage connections are at the bottom of the control, as we'll see next. Here are the primary pump connections. 2 connections for 2 primary pumps. And this is the boiler bank. As I said before, there are 4 boiler banks. And you can see that we tried to separate them with color. So the first boiler bank is white. And then the third one is white as well. So there is that separation between each of the boiler banks just to make it a little bit easier for you. Each boiler bank has 6 terminals. We have the mod plus and minus terminals to connect to a modulating boiler. And we have the relays for the stage 1 and the stage 2 connections for the on-off boilers. And remember, we can use the stage 1 if our modulating boiler also requires an enable. We can control up to 4 boiler pumps as well. Now these are just dry contacts, so we don't provide power out to the pumps. It's just a contact closure. And here we can connect to our indirect domestic hot water pump. So we're coming to the close of this presentation. In summary, we covered 5 applications, and those applications showed the possibilities to operate a mixed heating plant with condensing and non-condensing boilers. We also talked a lot about the indirect domestic hot water operation, so IDHW, and how we have moved away from modes, and now we configure the indirect domestic hot water based on location. Is it piped near the boiler, or is it piped on the boiler system? We'll talk about that more when we get to the technical presentation, because that selection also leads to follow-up selections on, do you want the primary pump to operate for indirect domestic hot water as well? We looked at a dedicated domestic hot water application, and we also saw an application where we were sequencing the primary pumps and doing indirect domestic hot water, and in that application we were also sequencing domestic hot water pumps through a 132 pump sequencer. The features that we covered included 10 new features to the 284. In particular, we wanted to look at how it can control the mixed heating plant, how it treats condensing and non-condensing boilers differently, how we can wire and control up to 4 modulating single-stage or 2-stage boilers. We looked at outdoor temperature reset as one of the possible application modes, and the 4 other application modes. If that wasn't the type of system we had, we can configure it to operate for a fixed set point, for dedicated domestic hot water, or to receive input from an energy management system or a building automation system. We looked at BACnet or Modbus communication to a building automation system, and we did say that we'll cover that more in an upcoming webinar, and that more information can also be found in the B manual. tekmarNet communication, which you're familiar with, but we did look at how we have 4 boiler buses so that we can connect to up to 96 tekmarNet devices. We looked at the performance monitoring capability of this control, and how we can measure energy, flow, and pressure and report those performance indicators back to a building automation system so that building owners can confidently manage their buildings from a distance. We looked at how the primary pump sequencing function is a little bit different in the 284 in that it has 2 attempts this time, so that we make sure that before we shut that system off, there is indeed a problem. We tried twice. Again, we looked at the Setpoint Operation and how we can receive a Setpoint call from either a contact closure, how we can receive a Setpoint call from communication from a tekmarNet for Setpoint control, like a 161 or 162, or how we can receive that Setpoint call from a building automation system. And we also looked and talked about the touchscreen user interface and how it's very easy to navigate the menus. We can use the next and the back item buttons so that if we skip an item or want to revisit an item, we don't have to scroll through all of them. We also saw how this control displays the boiler output so that we can see at a glance how our system is operating. And lastly, we looked at the wiring, how we wire calls to this control, how we wire the sensor input and communication, and how we wire the boilers and the pumps. In particular, we looked at how there are 4 boiler banks, and each boiler bank has 6 terminals so that we can wire up the type of boiler that we have. In summary, the 284 is a flexible solution for commercial and multi-residential heating plants. It works to maximize efficiency based on your system, and it saves energy with customized boiler sequencing. And it has more features to provide the best in boiler plant control. The 284 is a boiler control with superior functionality and advanced features. It is the most flexible product in the market. It's easy to set up and install, and it's also positioned at an affordable price range. The tekmar 284 is the better design and the better control for a better system. As always, additional information can be found on our website, www.tekmarcontrols.com. You can easily download all of the manuals that are associated with the 284, including the Installation Operation Manual, the Application Manual, the BAS manual that I talked about that includes more details on what you can read and write using BACnet or Modbus. We'd love to receive feedback for you or answer any questions that you may have after watching this presentation. You can email us at learn@tekmarcontrols.com and we'll get back to you within the same day. Thanks very much for spending the time with me to learn about the Boiler Control 284. I hope to hear from you again. My name is Elizabeth Brown. Have a great rest of your day. Bye-bye.